using the function below here, this graph, we'll call it g of, I'm going to switch this to t. I think I just copied that down wrong. G of t, we're going to determine the limit as t approaches b for b equals 1, 2, 3, 4, and 5. So let's go ahead and start with b equals 1. Okay, when b equals 1, we're looking for the limit as t approaches 1 of g of t. So let's go ahead and take a look on our graph. Here's 1. Okay. Now, the actual height value at 1, I don't really care about. What I do care about is what's happening to the function as I get values that are closer and closer from each side. So let's go ahead and take a look from the left side. So we would write from the left side, that's the limit as t approaches 1 from the left of g of t. And what that is as I come closer and closer, what are my height values doing? And my height values are getting closer and closer to 0.5. The other way I like to look at this, let me draw that line back in. Close enough. So the other way I like to look at this is if I'm actually traveling along the line, what do I approach? What height value? Well, I don't really care about this value right here, but I care what I approach, and that's 0.5. Okay, now from the right side, you've got to look from both sides. If you only look from one side, it's not correct. So that is the limit as t approaches 1 from the right side of g of t. And so that means as I come in this way, what height value do I approach? Well, I approach 0.5 again. And since these guys are the same, we conclude that the limit as t approaches 1 of g of t is equal to 0.5. Okay, so that's it. That's all we do for b equals 1. I'm going to erase this, and now let's go ahead and check b equals 2. So when b is equal to 2, we want to see the limit as t approaches 2 of the function. Okay. So again, we'll take a look here. As we come closer and closer to 2, from the left side, so the limit as t gets close to 2 from the left of g of t, looks like it's approaching a height value of 1. So this is from the left. From the right, as if we look at the limit as t approaches 2 from the right, coming in from this direction, looks like our height values are getting closer and closer to 1 again. So we would say that the overall limit, the actual limit as t approaches 2 from both sides, that's what this guy means, from both sides, it's equal to 1. I want you to notice, and I think on the actual graph in the book, they've got a little dot up here. I want you to notice that if that's true, then g of 2, okay, is actually equal to 1.5. However, the limit is only equal to 1. So this guy right here is not the limit. It's what the function is at that point. But we care what is it doing close to it, but not actually at it. So our answer here should be 1. Okay, now let's go ahead and take a look as we approach 3. So as we approach 3, so the limit for the t, as t approaches 3 of the function, what happens? Well, let's take a look at the left. The limit as t approaches 3 from the left is equal to 0.5. Now let's look at the right. The limit as t approaches 3 from the right side is equal to 1. So therefore, the limit as t approaches 3 of g of t does not exist because these guys don't match. Additionally, g of 3 is equal to 0.5. The function at 3 is actually equal to 0.5. However, the limit does not exist. You should make sure that when you're working through these problems that this notation isn't a problem for you. Okay, because it's important to get it down. So let's take a look at 4. So what is the limit as t, the t value, gets close to 4 of g of t? Well, as we come in towards 4 from the left, and as we come in towards 4 from the right, they're both the same, and so that's equal to 1. And then lastly, do this guy in yellow here, the limit as t approaches 5. Well, as we get closer and closer to 5, this guy goes up indefinitely. So the limit as t approaches 5 from the left of g of t does not exist. Sometimes you'll see people write this. The limit as t approaches, let me write that a little bit better. The limit as t approaches 5 from the left of g of t, they'll put positive infinity. What they're doing is they're describing the behavior of the function. However, this is the same as saying the limit does not exist. But instead of just saying the limit doesn't exist, what they do is they go through and they say equal to infinity, meaning it doesn't exist, but we can tell you what the function is doing. Same thing over here from this side. As we approach, if I make this a positive, same thing holds. And so again, people might say the overall limit, since from the left and the right they're both infinity, some people might say infinity or positive infinity. But the best answer for you to probably write down is does not exist, because the limit doesn't exist at those values.